Today we're working on 7.5, which is solving special types of linear systems. And the first thing we're going to look at is a linear system with no solution. We kind of talked about this back in 7.1 already when you did that joke sheet for me. And I believe the seventh problem on the joke sheet had two lines that were what kind of lines?
Parallel.
Parallel. And we said, hey, the solution to that is no solution. Kind of gave you a, yeah, that's going to be on there, and we'll talk about it later again. Here we are today. So we have two things. One of them is a linear system with no solution. I have two equations up here, and they need to be graphed. You could graph them using the x-intercept, y-intercept, or you can graph them using slope-intercept. I'm going to pause a moment for you to graph. And looking at our graphs that we have up here, we have two lines that are graphed. They each have the same slope. So therefore, the two lines do not intersect. They're parallel. And when I look at this kind of a graph, I look at it and I say the solution to this system is?
No solution.
No solution. There we go. We're going to have no solution because the two lines are parallel to each other. The two lines are parallel. So when you graph for me on your test and you come up with two lines that are parallel to each other, that is your graphical way of showing me that those two lines do not intersect, and thus their solution is no solution. Now what happens if we want to instead use the elimination method in order to come up with this? Well, we have our two equations, 2x minus 3y equals 6. And 2x minus 3y equals negative 4. I want you to talk to your partner. I want you guys to come up with the elimination method to do this in order to show me what happens with your variables, please. When we are looking at eliminating these, what's the first thing that we have to do to one of the equations? Michael? Okay. Does it matter which one I multiply through by a negative 1 on?
No.
All right, so let's go ahead and we'll just do the top one here. So negative 2x and positive 2x, what does that give us? 0. Yeah, nothing.
Oh,
0. It's a number, right? 3y minus 3y gives us?
0.
0. Good, you learned. Equals negative 6 and negative 4 gives us?
Negative 9.
Uh-oh, my variable's dropped out.
No solution.
No solution because?
Oh, yeah.
0 does not equal negative 10, exactly, because this is a false statement. So if you were doing my test and you came up with your elimination method of all the variables dropped out, Mrs. Deegan, well, look at your statement that's left. Is it a true or a false statement? If it's false, there is no solution. So there are two ways of looking at a system, and when you're solving them, what might happen? We have our graphing where you might have parallel lines. That's no solution. But those same parallel lines, how does it look when you're doing elimination method? All the variables drop out and it's a false statement. Evan?
Will there be any times where it's a true statement, or are we getting that later?
I'm getting that just a little bit. Okay? You're thinking ahead though. That's good. Anybody else? Jake?
So by doing the elimination method, that proves that your no solution answer is correct?
Well, no. What I'm saying to you is if I have you working on an elimination problem and all your variables drop out and you get a false statement, it's a no solution problem also.
Alright, is there a way to check these or you know?
No. No, there's no way to check these. Okay, anybody else? There's no point to put back in.
Yeah.
So, all right, let's go on to this next one. Linear system with infinitely many solutions. Think through here, Evan. Infinitely many solutions. I have my two equations that I need both of those lines graphed. So I'm going to pause so that we can have everybody graph those.
Wait, what?
All right, ladies, gentlemen. We have it graphed up here. As Evan graphed the first one, all of a sudden Tyler's like, hold it, it's already graphed. They are the same line. When you graph two equations and they turn out to be the same line, then there is an infinite number of solutions. Now, this is what we write down. There's an infinite number of solutions. I don't know what they all are. I can't come up with every one. I just know there's an infinite number because every point that lies on this line is a solution. Absolutely every XY pair, all the fractions, decimals, and the integers you can come up with on that. Please do not say to me all real numbers, because is this point on the line? No, how about this one over here? No, so there are some real numbers that don't work, but there is an infinite number of solutions. I can't give them to you all, so I'm not even going to try. Okay? I need to know that there's an infinite number. Now, the other thing that I want you to do is the elimination method. I suppose I could probably even say to you, possibly the substitution method on this one too. It might work out. Tyler's going to come up and do that for us. Here, you guys are going to work at your seat. Okay, Tyler used the elimination method up here. He brought the 2x over so that it became negative. The 2x right here, he took over to the other side to line things up. So we had our negative 2x and our y. Then he multiplied by 2. And what happens is all the variables drop out. Okay, all the variables drop out, and we get what kind of a statement? No. What kind of a statement? True statement. Therefore, infinite number of solutions is our answer. Okay? Infinite number of solutions is our answer. I don't like whoever wrote that a long time ago when I had this. I don't like how it's written. Maybe it was me. Number of solutions. You can use the number sign. Yep. Tyler?
Would you write true statement for the answer too, or?
Nope. True statement is not the answer. That's what you're thinking, and that's why there's an infinite number of solutions. But true statement is not the answer. Okay? Just like false statement, I don't take that as the answer. You have to tell me that there is no solution. All right, questions here. Story problem time. Think. Let me look at this one. Yep. You know what? Before Ev leaves, if we can just talk real quickly here for just 1 second. We're going to solve this linear system we're going to come up with how many solutions it has without solving it. You may not graph. You may not use the elimination method. You may not use the substitution method, but you have to tell me how many solutions it has. Any ideas on what to do, Josh?
Solutions.
Why do you say that?
Because you can multiply the quotient by 2 and everything, you just cancel that.
Well, I said you can't use the elimination method, Josh. Ooh. Adam.
You multiply by a -2 and it's a complete, like both of them are the same equation.
Can't use the elimination method. Okay, because both of them are the same, that would get you a true statement. Mr. Michael.
The top one's just a negative, simplified one at the bottom.
Not necessarily. What I'm hoping to have you guys do here is put this into y equals mx plus b form and look at the slopes. What kind of lines have, what is the slope of parallel lines? Same. What is the slope of two lines that are the same line? Ooh, they're the same. Ooh, okay, now hang on. But on lines that are the same, they're going to also have the same what? Y-intercept. Will parallel lines have the same y-intercept? No. How about if I put them in y equals mx plus b and they don't have the same slope? There is one solution because those two intersect. So I might give you 3 different problems, and you should put them in y equals mx plus b form and look at their slopes and their y-intercepts. If they have the same slope, different y-intercept, they're going to be parallel. Same slope, same intercept, they're going to be the same line. Different slopes, they're going to intersect, and there's going to be one solution. So I wanted to make sure that you took away before you left. Okay? So we're going to talk more about this, but I wanted to make sure you at least had that. Okay. So moment and put these in y equals mx plus b form for me? In putting these in y equals mx plus b, we notice that the two equations are exactly the same. So how many solutions does this system have?
Infinite number.
Okay, on your test, I'm going to ask you a problem like this, and what you have to give me is that there is an infinite number of solutions, and you're not going to be allowed to graph it, and you're not going to be allowed to use the elimination or substitution method. I would highly recommend to you that you write them in y equals mx plus b to show me that they have the same slope and the same y-intercept. Now, these lines here, I didn't tell you what these same lines are called. There's a special word for them. These two lines are called coincidental lines. Yes, you should know the words coincidental lines because I will be using them. Okay, the book uses them. That's just vocabulary that you should know. Coincidental lines. They are two lines that are the same line. One line lies on top of the other. Okay? The equations look different, but in the end, if we write them in y equals mx plus b, they're going to look exactly the same. Jake?
So, could you say for your answer, would you say coincidental lines or infinite number of solutions?
The question will be, how many solutions are there? What do you think the answer should be if I'm asking how many solutions are there?
Infinite.
Infinite number of solutions. If I ask what kind of lines are these, they're coincidental lines. They coincide. They coincide. That's why they're called coincidental. Okay, I'm going to go back up to this thing here where it says identify number of solutions. We were just talking about it a little bit ago, and I wanted to get to see that information prior to Ev leaving. So one solution, when it's in slope-intercept form, what can you tell me if you would look at the two equations? What do you see when it's in slope-intercept, Jack?
Different slopes.
Different slopes. Okay, that's all that we worry about. We got different slopes. Could they have the same y-intercept? Possibly. Yes, no? Yes, because they could intersect at the y-intercept, but they're going to have different slopes when there is one solution. How about when there is no solution, please? Harrison?
When they're the same slopes, but different y-intercept.
Same slope, but Harrison put on there they have to have a different y-intercept, and that's very important. Because otherwise, these two lines would be one line on top of the other, and that wouldn't be the same thing as no solution. Infinitely many, or an infinite number of solutions. Josh?
Same slope and different intercept.
They have the same slope and the same y-intercept. That is important because in essence they are the same line. They're coincidental lines. So when you're looking at the information and you get them in y equals mx plus b, they're going to have the same slope and the same y-intercept, whereas no solution has the same slope, a different y-intercept, and one solution just has different slopes. Any questions there? All right, we've done that where we solved, and here we have a story problem. We have two groups of people are buying pizzas. Number of pizzas and total cost are below. How much does a large cost and how much does a medium cost? Okay. You guys should be able to set up equations for these. And would you go ahead and work with your partner and solve? And looking at these two equations that Jake wrote up here, 4x plus 12y equals 168, and 8x plus 24y equals 336. He says x is the number of medium pizzas, and y is the number of large. I like that he told me what they were each were. Those two equations are correct. Now, if you start solving that using an algebraic method, what happens?
0, 0.
They all cancel out. What kind of statement do you get at the bottom? 0 equals 0. So how many different answers are there to this problem?
Infinite number.
Infinite number?
Or no answers.
How did you guys add them together? What did you multiply the top equation by? So we're multiplying this by -2, so we really are getting -8x minus 24y equals negative what over here? 336. So we did get 0 equals 0, which tells us infinite.
'Cause that's a true
Infinite
statement.
number of solutions. So can I tell you how much a large costs? Can I tell you how much a small costs, or medium, whatever it is? No. There's a whole bunch of answers that are possible, but I can't give you the answer. Now, what if that had been a false statement? There would have been no solution to the problem. Those might come upon your problems today. You have an infinite number of solutions because when you added your two equations together through the elimination method, all of the variables dropped out and you got a true statement. We could graph that line and we could find all different solutions. Do you want to do that?
No.
You just have to find points that are on the line. Can you find solutions to an equation that are on the line? I've asked you before, is 3, 4 a solution to the equation? What'd you do? Plug the numbers in and see if it made a true statement, right? So if you graph it, you can look for points that lie on that line.
So it could be any point.
Could be any point on the line, so there could be more than one solution to the problem. And in fact, there's an infinite number of solutions. Now, some of those are negative numbers, right? And some of those are positive, really big positive numbers. Would a pizza costing, maybe $150 be reasonable for a medium? Probably not, but could that be a solution? Possibly. Right. Somebody else had a question. Adam?
Well, how could a medium, like if a medium pizza costs $150, then how would, like, then 4 medium pizzas is more than the cost?
Sure. I took a really big number. Sorry, I kind of pulled one out of the hat. But technically, anything on that line will work, right? It sounds like we need to graph this and find out if there are some solutions. Should we graph? Let's go ahead and graph. We need to graph. Oh, you poor people. Whoops, I don't want those. It's all their fault. Oh no.
The world is ending
The world is ending.
in 1 year.
No, it's not.
one major.
It has to be a point on the line. So this could be our medium, and this is our large. This is our medium, this is our large. We could find other points. If you made your graph go by ones, it'd be easier to find the points. I went by 2, so I can fit it all on there. But if I go down 2 and to the right 6, here's another point. 2, 4, 6, 8, 10, 12, 14, 16, 18. So $18 for the medium, 2, 4, 6, 8. $8 for the large. Sounds a little backwards, doesn't it? But does it work in the equation?
Oh, that just
Yes.
got me more confused.
Yeah,
But
I agree.
ladies, gentlemen, are there points? There are many points on this line that'll work, right? That's what I'm saying to you, is that there's an infinite number of solutions. Do they all make sense? Absolutely not, because some of them, when I go up this way, are going to be negative numbers, right? We don't have negative money, so thus we throw out some of the solutions.
Credit cards.
Credit cards, negative. All right.
Credit cards,